Problem 4. Write a query that gets person last name, first name, and gender description. The query should get all rows from person, even if the gender is null. For this, we needed to use an outer join. A couple of quick things to note about outer joins. When you're defining the joins, the word outer is not required. So as you can see in my example, I've used the words left join, and that means it's a left outer join. This holds true for any outer join. You're never required to use the outer keyword, but you can if you want to. When we talk about left and right in outer joins, we're just referring to which side of our join definition the table is listed on. So in this example, the left table is person and the right table is gender. If we were to switch the order of these in our definition so that this said gender left join person, that would be a different query with different results. A left join gets all the rows from the left table, regardless of whether they have a matching row in the right table. So here, we're getting all the rows from the person table, whether the rows have a gender or not. As you can see, a few of these people have a null gender in the database, just meaning their gender hasn't been entered in the database yet for whatever reason. Problem 4b, modify the query so that it's a right join instead of a left join. How do the results differ? So all I've done here is change the word left to right, and now this is a right join. And my results are going to differ in that now we're going to get all the rows from the right table, gender, even if they don't have a row in the person table. If you look at the gender table, you'll see that there's a row for male, there's a row for female, and there's a row for unknown. So let's look at that really quickly. Male, female, and unknown. So this query will get rows for each of those three genders, even if not all of those are represented in the person table. I've sorted these results so it's easier to see. So if we scroll down, we'll see the male rows, then the female rows, and finally we get to a row for unknown. But we can see that the person last name and person first name in that row are null. From this result, we can tell that nobody in the person table has been assigned unknown as a gender. Problem 4c, modify the query so that it's a full join. How do the results differ? Now I've just changed the word right to full and made this into a full join. In a full join, we get a row for every row in the person table and a row for every row in the gender table, even if they don't have matching rows in the other table. When we look at the results, just like in the left join, we get a row for each person in the person table, even if there's no matching row in the gender table, so the ones that have a null gender again. And also, we get that row for unknown, even though it doesn't have a matching row in the person table. So a full join is just a combination of a left join and a right join. Problem 5. Write a query that selects person last and first name, person ID, and staff ID so that a row is selected for every person in the person table, even those who are not staff members. Last name and first name should be displayed in one column in alias name, example Adams, Rosalind, and the query results should be sorted by last name, then first name. To solve this problem, I used a left outer join. Now, if you had wanted to, instead of doing person left join staff, you could have done a staff right join person, and that would have gotten the same results. We're selecting the person last name and the person first name from the person table, and we're concatenating a comma and a space in the middle so that the name is displayed in the format last comma first. And we're aliasing that column as name. And we're also selecting the person ID from the person table and the staff ID from the staff table, and left outer joining person and staff where the person ID equals the staff ID. And then finally, we're ordering the query by person last name and then person first name. So if we had used a regular join, an inner join here, we would have only gotten rows for people who were staff. In other words, we would not have gotten a row for people in the person table who did not have a row in the staff table. But with the left join, we get a row for every record in the left table person, no matter whether it has a matching row in the right table staff. So what we end up with here is a column with the name, a column with the person ID, and then a column with the staff ID. And the value in that column is going to be null unless that person has a row in the staff table. So the people with null in the staff ID column are not staff. Problem 6. Write a query that selects the staff ID, staff last name and first name, staff employment site description, and appointment ID or IDs for that staff member. The query should select all staff members regardless of whether they have an employment site defined in the staff table. It should select a row for each staff member and a row for each appointment, regardless of whether there are matching rows in the staff and appointment tables. So for this query, we had to use 3 different joins. We have an inner join, a left join, and a full join. We inner join staff to person, so we get the last and first names of each staff member. Then, to get the staff members regardless of whether they have an employment site defined in the staff table, we left join staff to site. So this gets all the records from the left table, staff, whether they have records in the right table, site, or not, since we ordered the query by site description. We can see that these top 3 staff members are the ones who don't have an employment site in the staff table. The rest do. And we'll get to rows 4 through 7 in just a minute. Now, in order to get a row for each staff member and a row for each appointment, regardless of whether there are matching rows in the staff and appointment tables, we have to use a full join. When we do a full join on staff and appointment, we're going to get all the rows from the staff table, regardless of whether there are any matching rows in appointment, and all rows from appointment, regardless of whether they have a matching row in staff. So as you can see, we're getting rows for staff that don't have any scheduled appointments. Those are the ones where the appointment ID is null. And we're getting rows from appointment where there's no matching row in the staff table, which is rows 4 through 7 here. These are appointments that have no staff assigned to them. All the rest of the appointments do have staff assigned to them. So, incidentally, if you were to change this full join to a left join, those 4 rows are the only rows that would no longer be selected, because then you'd just be getting all the rows from the staff table, regardless of whether there are any matching rows in appointment, not the rows from appointment that don't have a matching row in staff. So remember, you can combine several different types of joins in one query, like we've done here. Using an inner join will get you only the rows where the join condition is met. Outer joins, depending on what kind they are, will get all rows from one or both tables, whether the condition is met or not, like most likely get some null results. Finally, really quickly, I want to go back to one of the queries we looked at in Module 3 and make it more practical as I said I would. So the top query here can be rewritten to get the bottom query, which we've joined up to the site and position tables. And now when we run the query, we can read the site description and position description of these staff members instead of just getting the site codes and position codes.